ThorImage LS provides a complete software solution for our microscopy platforms. In this video, we will demonstrate multi-channel confocal imaging, high-resolution image tiling, 3D image stack functionality, and multiphoton fast Z capture. First, we'll image a rat hippocampus using confocal fluorescence. To image our glial cells, we enable the MCLS multi-channel laser at 488 nanometers. Next, we set the PMT gain and take an image. The settings of this light path can be saved for future image acquisition. The second image will feature neurofilaments, which are stained with a different fluorophore. So let's deactivate the 488 nanometer channel and activate the channel at 561 nanometers. We also activate and set another PMT here, which is paired with an emission filter tailored for this wavelength. The settings of this light path can be saved independently of the previous acquisition. Multiple fluorescence channels can be captured at the same time by enabling both laser channels and setting the gain on both PMTs before taking the image. The glia and neurofilaments in the sample are then imaged in quick succession to minimize spectral crosstalk. This method is ideal for acquiring large sets of multi-channel fluorescence images. Saving multi-channel settings follows the exact same format. The same sample can be acquired at high resolution via tiling. A tiled image can be set manually in the Tiles control panel by setting an active area range. Let's also specify that the center of the tiled area matches the current XY position of the stage. Clicking Snap takes an image of the center tile in our active area. We can select a different tile to image as well. Using the Capture tab, a tiled image can instead be acquired automatically. The captive area was previously set, so clicking Start will acquire the 9 tiles specified in the Capture Setup tab. These images can be saved as either OME TIFFs or RAW files for stitching and image analysis. Associated metadata is saved as OME XML and text files. Now, let's take a 3-dimensional image stack of an in vivo mouse brain labeled with YFP. Using the Z control panel, we set one location in Z to acquire a test image first. An image stack necessitates setting the starting and stopping Z locations, as well as the step size. Now that those are set, once we start the acquisition on the Capture tab, ThorImage will capture the Z stack at those settings. We can also perform real-time ROI analysis as it acquires the image set. Let's pick an oval shape and set 4 regions of interest to analyze the average image intensity in each ROI as a function of Z. Once the acquisition is complete, the Review tab allows us to view our Z-stack. We can choose to show the most recent capture or select a different experiment to review. To see the entire image stack in cross-sectional form, we click on the cross-section icon. XZ is below the XY image and YZ is to the right. Moving the mouse samples different XZ and YZ slices in the stack, as defined in the Z-axis settings. The play button scans through the Z-stack as a video. The image stack can also be viewed in 3D. The axial view is adjusted by opening the options and using the directional buttons. We can also use the mouse to click and drag the view of the stack. Once we let go, it revisualizes the stack. To show multiphoton fluorescence, we're going to image a stained mouse kidney. The galvoresonance scanner will be used to scan the sample with light from the tunable laser. The laser wavelength is set to 680 nanometers, and the laser shutter is controlled by ThorImage LS directly. Clicking on the live icon shows a real-time image. Since we're taking an image stack, let's determine where our sample slice begins, set that as the starting Z, then figure out where it ends, and that'll be the ending Z. This time, we're going to take a fast Z-stack, which is only possible with a piezo objective scanner and a galvoresonance scanner. Because the software captures the Z-stack at a high speed, we have to specify in advance one Z to preview, called the preview index, as well as the file name the Z-stack will be saved as. During the fast Z capture, the screen shows a frame from the middle of the stack in the top left, the starting frame in the top right, the ending frame in the bottom left, and the preview index frame in the bottom right. Now let's look at our acquired Z-stack. When specifying a region of interest with one of the ROI tools, ThorImage LS calculates the image intensity over the ROI as a function of Z. We can step through the image stack manually by moving the location tool in the ROI analysis window, or click on the play button in the Z-axis settings to play through the entire Z-stack as a movie. These are only a few examples of image sets ThorImage LS can take. We are continually improving and expanding our software's functionality with free updates and open source availability. For more information, please contact us at techsupport@thorlabs.com.